Lesson time, yes. Happy lesson time is here again. Here we go. We're on Module 6, Decimals, and Lesson 2. Let's see what we have today. Here's what we'll be doing. We're going to use metric measurement. Okay, so metric measurement. Talked about that last time. And area models. Stop and think. Okay, area models. I remember what those are. To represent tenths as fractions. Okay, we did that already in Lesson 1. Tenths as fractions greater than 1 and also as decimal numbers. Let's see what that looks like in practice. First, a little warm-up. We did a little bit of this yesterday there, last lesson. So say the whole. What's the whole? You see I'm circling it there for you. It's 100. Okay, so how many parts is it divided into? Well, you don't have to count with your finger. I'll tell you. It's 10 parts, of course. That's what we're doing, decimals. Everything's powers of 10. So it's divided into 10 parts. What would the division sentence here be? So we took 100 and divided it into how many parts? Into 10 parts. And each part is then equal to 10. So the division sentence would be 100 divided by 10 is 10. Excellent. All right. So now what's the division sentence? We'll take the whole 10, divided it into how many parts? 10, and each part is 1. So what's the division sentence? 10 divided by 10 equals 1. Perfect. All right, now how about this bad boy? 90, again divided into 10 parts. Each part is 9. So 90 divided by 10 equals 9. Excellent. Another one. Oh, similar idea here. 990 now divided into 10 parts. Each part is 99. Excellent. So 990 divided by 10 equals 99. Ooh, there's an interesting one. 6,990. Yeah, say it for me. Divided into 10 parts. Each part is 699. All right. 6,990 divided by 10 equals 699. There's another one. See, don't let this zero do anything to your head. All right, 5,080 divided by 10 is 508. See how that works? All right. Now let's do something different. So say this fraction. 1/10. Very good. Okay, now how would we write that as a cute little decimal? Now the way we'd read it is 1/10. Right? 1/10 equals 1/10 is what we'd say. But how would I write it? Remember I said there's a distinction here between reading it as a math number and then answering the question, well, how do I write this? So how would we write it? We'd write it as 0.1 is how we could explain how to write it. But when we read this as a number, let me be clear, you don't say 0.1, you say 1/10, just as you would for the fraction. All right, let's step it up. Say the fraction, 2/10 as a decimal, 2/10, which we'd write as 0.2. 2/10 equals 2/10. How about this one? Say the fraction. 7/10, good. And as a decimal, 0.7 is how we'd write it. 7/10 equals 7/10. How about that bad boy? 9/10 is the fraction, good. And as a boy, you're getting quick at this. All right. Yes, 0.9 is what we'd write. 9/10 equals 9/10. Now do it the other way here. Ooh, tricksy. I give you the decimal. 3/10. 0.3 is how we'd write it. As a fraction would be, there we go, 3/10. And how about this? You got it. 4/10 equals 4/10. Oh, you're getting good at this. 8/10 equals 8/10. And how about, yes, 6/10 equals 6/10. You see, these are equivalent. So what I really want to stress here too is that equal sign. That this fraction is the same thing as this decimal. If I give you 6 out of 10, I give you 6 out of 10. It's the same thing. 6/10 equals 6/10. Ooh, there's something new. We'll read it as a fraction, 10/10. Okay, and as a decimal we'd write, ooh, now this is interesting. Watch what happens here. It equals 10/10, which we see is 1. You see this 0 here, all right? That 0 is in what place? When we talk about place value, what place is it in? It's in the 10th place. So notice we see the number 10 here. If we kind of ignore the decimal for a moment, we see the number 10, and what place are we in? Tenths. And we'll be coming back to that later on, especially when we get to hundredths. This is a way of thinking about it. 10 tenths. What's the number I see? 10. What place am I in? Tenths. Okay, keep that in mind. And of course, we can look at that and say that's 1, or you might say 1 whole. All right, let's count together by tenths, starting at 0 tenths. 0 tenths, 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, 10 tenths, which is equal to 1. You got it. All right. Now do the same thing in decimal form. So we're starting from 0 tenths, and that is how you read this number. You would read this as 0 tenths. Yeah, how about that? So now 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, 10 tenths. Excellent. Nice job. And of course, that number is also still 1. All right, so Ben, here we go. Ben, ooh, get that right. All right, Ben, planting bamboo, it grew 5 tenths centimeter. That's how you read that, 5 tenths centimeter. That was yesterday. But today is a new day, and today it grew another 8 tenths centimeter. And notice I've written it as a fraction in this slapdash way because it's a pain to format it top and bottom, numerator, denominator. So I was a little lazy here and just put the slash there, which you see done. So that's the fraction 8 tenths. How many centimeters did Ben's bamboo plant grow in 2 days? Okay, so to draw a tape diagram here, we have yesterday and we have today, and we're wanting to know the total for the 2. So when we're putting things together, yep, I heard you, we're adding, yes, so we're going to have one tape, right, to put them together. So B is for bamboo, or maybe it's for Ben, or Ben's bamboo, 5 tenths centimeter. And what did I do with it here? Right, I wrote it as a fraction so that I'm writing them both the same way, and then we have 8 tenths centimeter. Well, this is, you're like, man, I know how to do this. We did lots of this. Yes, adding fractions. So 5 tenths plus 8 tenths. How much did it grow in 2 days? What'd you get? Well, our first stop is at 13 tenths, right? But that's a, what's that called? An improper fraction, right? Improper because the numerator is more than the denominator. It has a value greater than 1. So it's an improper fraction. We like to make those normally into mixed numbers now and then. So that would be 1 3 tenths. And you already learned all that, so I'm not going to explain how we did that. If you need to, go back and review that lesson. Okay, so B there, the total for the 2 days is 1 and 3 tenths centimeters. And notice I said and because this is where you use and in mathematics. 1 and 3 tenths centimeters. So our little statement would be, hey, Ben, lucky Ben, also known as Obi-Wan, his bamboo plant grew 1 3 tenths centimeters in 2 days. Nice job, Ben. Nice job, bamboo. Let's move on. Here we go. We are going to draw line segments. What? Draw line segments? I thought we already finished geometry. Well, check it out. We're going to express each segment, its length, as a mixed number and a decimal. Okay, so here we go. You will need a pencil, paper, and ruler to do this one. So go ahead and draw a line that measures 2 centimeters. Now, obviously, my ruler here is blown up big. That's not to scale. That's not what 2 centimeters look like. I'm just making it big so you can see it. Okay, so if you need to pause the video, go ahead and do that, but draw a line that's 2 centimeters long. Okay, now extend the line by 6 tenths centimeters. Okay, that not to the point of the 6, but extend it by 6 tenths centimeters. Okay. Oh, and notice what else? Yes, it's not 6 centimeters I'm asking you to go, say, from 2 centimeters, hopping up all the way to 8 centimeters. It's 6 tenths. So now we're looking at these little lines here. We'll just call them little lines for now so we don't confuse ourselves. So we're looking at these little lines, and we're going to go 6 of those little lines, okay? So there it goes. Now it is 2 and 6 tenths centimeters, okay? Ooh, that's a little tricky, isn't it? All right, we got it, though. Now draw one line segment that measures 3 and 5 tenths centimeters. We could even say 3.5 centimeters, right? Because we know 5/10 from our equivalent fraction work is equal to 1/2, but let's say 3 5/10 centimeters. So there's 3, and then 1, 2, 3, 4, 5/10 will be the long line there, tall man. All right, so there's our 3 5/10 centimeters line. Beautiful, nice job. And notice I express it here as both a decimal and as a mixed number, just to mix things up for you. All right, so now let's draw one 4 8/10 centimeters. You'll go 4 centimeters and then count off the little lines, the 8/10. All right, and throughout here, I'm just going to move through this. You can pause if you need a little more time to draw those lines, okay? All right, and expressing it as both a decimal and as a mixed number, 4 8/10 centimeters equals 4 8/10 centimeters. Notice we read those the same, the decimal and the fraction form. Now let's do 1 2/10 centimeters. Well, go to 1 centimeter and then 1 2/10, and you see where you end up there. Great. 1 2/10 centimeters equals 1 2/10 centimeters. All right, let's go all the way out to 6 9/10 centimeters. All the way out 6 centimeters and then another 9/10. And we can see how that looks as both a decimal and a mixed number. 6 9/10 equals 6 9/10. All right, so that was just drawing lines, great. So we're using length, relating it to decimals and fractions, mixed numbers. Now we're going to use area models, okay? So same idea, but with area models. And notice we're doing values greater than 1. So how many tenths are in 1 centimeters? Not a tricky question, right? I'm not trying to trick you here. It's what we just did. How many tenths are in there? Are in 1? How many tenths are in 1? There's 10 tenths, right? 10 tenths. All right. So how many tenths are in 2 centimeters? Okay, 20 tenths. You see that? 10 and 10 more is 20 tenths. Great. All right. Now how about 2 6/10 centimeters? Well, we'll do it this way. Look, 10, 20, and then we have 1, 2, 3, 4, 5, 6. So 20 and 6 is 26 tenths. And I hearken back to what I noted earlier, that see if this number, if you just read it as a number, the 2.6, if you say, read it as 26, and you say, what place am I in? Tenths. 26 tenths. That's a way of thinking about it there. All right, what would 26 tenths look like as a fraction? I wonder. Yes, it would look like 26 tenths. Wow. Was that fancy? Holy catfish bologna muffins. Yes, 26 tenths looks like 26 tenths. And we could write it either way. 26 tenths. We could read this 2.6 here as 2 6/10, but we could also read it as 26 tenths. All right. Wait. Does that also mean? Wait. No. Yes. Dun 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 dun. 2 6/10 equals 2 6/10. Improper fraction. Decimal, mixed number, equivalency. Huh! All right, what about this? Can I do it out here? Is it witchcraft? Is it magic? No, it's mathemagic. There's 1. You like my scribbling? All right, there's 2. More scribbling. And there's 6/10. See, so we've represented all these different ways. There's the area model, by the way, here. Here's your area model. 26 tenths is 2 6/10, is 2 6/10, is 1, 2 6/10 in an area model. They're all the same. 2 6/10. Amazing. 6/10 as a decimal, as a fraction, as a decimal, as a fraction, as a decimal. Okay, enough. All right, so now let's do this. Let's do 3 2/10. We'll start with the drawing. I've given us 4 palettes to draw on here, each divided into tenths. So if we start with the drawing, there's 1, 2, 3, and 2/10, right? Okay, 3 2/10. We see it? But how many tenths is that at all? Well, this was 10, 20, 30, and then 2 more makes, you got it, 32 tenths. How would I write that as a decimal? 32 tenths, I could call it, and I could also say 3 and a 2 in the tenths place, right? 3 2/10. How would I write that as a mixed number? Well, I just said it. I just read the decimal that way. 3 2/10 is, as a mixed number, 3 2/10. Amazing. Let's do another one just like that. 5 9/10. Starting with the drawing. 1, 2, 3, 4, 5 holes, right? So 5 wholes and then 9/10 of another one. How many tenths in all? Well, this is 10, 20, 30, 40, 50, and another 9 makes 59/10. What's that as a decimal? 5 and 9/10. What's that as a mixed number? I just said it. When you read the decimal, you're saying the mixed number. 5 and 9/10 equals 5 and 9/10. Sweet! All right, now you're on to the problem set. So you'll be doing the same thing, drawing line segments, whoopee! And there we go with the area model and the different ways of writing it. And again, on these lessons, I don't go through the whole problem set and exit ticket with you, just kind of like survey it with you. They throw in an extra question here, how much more is needed to get to 5? So like here in this letter D, you're doing 2 and 5/10, so you do 1, 2, and then 5/10 here. Well, how much more is left blank that you would need to get to the total of 5? And the same thing on the next one there. Exit ticket, same thing, but shorter. You draw a line segment, you do the area models, and then for the homework, of course, you can head off to my homework time video to do it there. Well, look what you've gone and done! You've done another Eureka math lesson. Lucky you! And I will see you next time. It is once again lesson time.